Hello, algebra students. So yesterday we started looking at combining rational expressions. I thought we'd also solve a couple basic simple equations today. So this guy, I think you should be set to go. So if you're watching this video and you've already done a couple, you should definitely pause it and work on these yourself first. So can you guys help me out a little bit? What should I do first to attempt to divide those two rational things?
Copy dot flip.
Copy dot flip is a great way to go because it says divide. Now, in the next section and in other sections in this chapter, and for the rest of your life, if you encounter mathematical stuff in your life, it depends who you are, you're never going to see this again. But this same problem is ubiquitous. It's everywhere. What would it look like in most other places? They'd go like big bar, and then this thing would be underneath. You guys know what I'm saying? But that would be the same problem. Exactly. You do copy dot flip still. So I'm going to copy dot flip, and I'm going to do some erasing since I don't have a lot of space. So see if I can remember this. Okay. So we're going to go like this. That's what it was, right?
Yeah.
Okay. So now I'm going to factor the pieces. I think I'll take one step at least to do with that. So this one's an easy trinomial, right? What are the factors of that guy? 5 and I can't hear. Speak up. If you're wrong, mistakes don't matter, right? Like, we make mistakes to grow. They matter once you're on a test, yeah. But like, as you're growing, it doesn't matter. So don't be afraid. So we've got x, minus 3 plus 5. Okay. Can this guy be factored at all? You could take a 3 out. Very nice. So we could go 3, and what's left is x, and then what's left is 13. And then this guy, what factoring technique do we call that we use on this one? Difference of squares. A difference of squares, right? So then that's what? X plus and minus 13. Man, you guys are quiet. I can hear the answers, but they're so quiet. Okay, so then the second bottom, we're going to say, I think factors as well. Cool. 10 comes out. What's left? X and 5. Okay, do we have any choppy stuff on this one? Yes. Remember, the reason I can now cancel stuff is because I'm multiplying by 1, because I've turned it into a product using factoring. There's other ways to turn stuff into a product as well. Factoring is just the most common one. So that goes away. That goes away. Anything else? I don't think so. So what's going to be left? Fully simplified, this is going to be 3x minus 3. 3 times the quantity x minus 3, I should say, over 10 times the quantity x minus 13. If someone were to ask me where this was undefined, you guys would tell me positive 13, negative 13, because even though we canceled that out, it was part of the original thing, and part of the original thing, if you were to graph this in your calculator, you'll see next week, there's something at negative 13, something suspicious. I'm not telling you what it is yet, but there's something there. Just trust me. And there will also be something at negative 5. It might be a little hard to see, but it's there. So we'll see that on the graph next week. Okay, so those are the places it's undefined. We look at the end answer and the components of that answer. Okay? All right, so the second one, there's not much to do here, but here we could factor it as how? Oh my goodness, my legs hurt. So we've just got 7 there. This you can take out of 3, I agree. What's going to be left? 4x and 1. Great. This guy I think you can also factor. Can't you say 4 is shared? What's left? This, by the way, is not the only way to do this problem. It's also difference of squares right away, or you could do difference of squares right now. It's kind of up to you. This is going to be what?
2x minus 10 squared.
Yeah, you could go 2x minus 10, 2x plus 10. That'd be fine. Or you could have pulled out the 4 and go 4x minus 5, x plus 5. Think about that in your head for a second. If you did it as 2x minus 10, 2x plus 10, both of those would share a 2. So you could pull the 2 out of each one, and that 2 out of each one would produce this 4. And each one, when you pull it out of the 10, the 5 will be left. You can, of course, write that down on paper, but that's consistent. Okay? The only thing that I think is going to be hard to factor this time is that top left. Why can't we just like divide by 12 and go about it that way like we did the first one today? Because why?
Because not all of them are divisible by 12.
Yeah, they're not divisible by 12, clearly, right? Like 12 doesn't go into 5 or 2. I mean, like it's bigger than them. So that's not going to work. This thing still might factor. In fact, I made it to factor so it would come out nice and cancel stuff. That's where I engineered this problem, so that you'd feel satisfied when stuff got chopped. Okay? So it doesn't have to be that way, but I made it that way. So let's take some space and review how to do that factoring technique. I'm just going to do it right over here on the right. Or no, let's do it on top. We can just move this guy. We're done. Let's do it on top. So review of how to factor this thing. 12x squared minus 5x minus 2. What do I do first to factor this?
Multiply the 12 to the 2.
And get...
Negative.
This is something you guys should all be able to do by Algebra 2. I taught you it in Algebra 1. My class could all like do it back in Algebra 1. By the time you get to Calc, you need to be able to look at something like that and be like, boom, boom, boom. Okay? So, factors of negative 24 that give me 5. You can just start guessing around. Oh, but I hear it.
Minus 8 plus
8 and 3? Negative 8 and 3. Sweet. Sometimes on some of your problems, you're going to have to get your calculator out and test some factors first. You're not going to see it right away like these guys did on this one always. That's fine. I did one yesterday with the other class. It was kind of hard. We had to, mess around with our calculator, experiment a little bit before we figured out the 8 and the 3. All right. But this is also a great way to strengthen your factoring techniques besides just being able to do this one, because it's really just a combination of all the other stuff you know. So you go 12x squared minus 2, and you rewrite the x using that. So I have negative 8x plus 3x. Really doesn't matter what order you do this in. I usually like to make the 8 go with the 12, stuff that comes out evenly, because then I just play grouping. Or in other words, I factor out what they share a bunch of times. I say these share
8. That's 4x.
4 and x. What's left? X and 3. If I pull 4x out of that,
That's 2.
minus 2. What do these share? I might have. So Mary's saying, well, maybe it would have been easier if I had put the negative 8 with the 2 and the 3 with the 12. I think she's right, but it'll still work. What do these share? 1. They don't share anything else. A lot of the time you could plot a negative 1 if it doesn't work. But you can just say, they share 1. Did I do the problem right?
Yeah.
I know I did. I know there's factors, and I know I did it right because those match. So I play what they share again. What do the big pieces share? They share this quantity. If you pull it out of that piece,
You're left with 4 plus 1.
if you pull it out of that piece,
Plus 1.
you're left with 1. Okay? If you know this technique, it does not take long, but you got to practice it and try to remember it and have that confidence. Okay? So I'm going to put that right here, right? Because that was right here. So 3x minus 2 and 4x plus 1. And now our rational function is ready for any possible cancellations. Are there any? Well, sure. I made it that way. Is that it? I think so. Sometimes not very much cancels. It just depends. Depends how engineered the problem is. If it's more like reality, less stuff is probably going to cancel. So this is 7, quantity 3x minus 2. And then we've got 12, an x plus 5, and an x minus 5. And that's about as simple as that guy gets. All right? Let's look at a couple equations to kind of wrap up for today, and you guys can have some time. So let me get this. So I'll leave it for a second if you're still copying. So that was simplifying. Now we're going to solve our first equations, and then 8-5 will do a lot more of them. These ones really don't require much thinking. You can solve them a few different ways, but if you just simplify like we've been doing, that's like enough. It'll be easy mostly. This first one is about what most of your problems are like. Anybody see something in this equation that I can like do something with, Ashley? Difference of squares. You guys, where's she seeing difference of squares? There, of course. So that could actually be changed into
Plus 5x minus 5.
plus 5 and minus 5. Sweet. So then we've got x minus 5 already on the bottom. So what happens?
You get x
It cancels. I'm a little iffy. You should be like, oh, there's like a minus there. Caution, danger, Will Robinson. But really, that's like a whole piece, right? So it's okay in this case to cancel it. And what's left is like really easy, right? So you just have x plus 5 equals 14. You subtract your 5 and you get 9? All right, just a quick check. Just like with radical equations, these can have extraneous solutions. You don't have to like plug it in all the way to check. You should just be cautious. One of the reasons we've been talking about undefined issues is because of right now. It's just one of the reasons. Because 9 might not actually work. It might be a fake solution. It might be extraneous. What would be a big problem? A big problem would happen if you put 9 in the bottom and you got 0. But do we? So we're probably good. I bet it works. And that's all you have to do. All right? Be on the alert for extraneous solutions. Let's try this last one for today. And again, there'll be more in my next video if you want to see more examples. Can somebody look at that and tell me, is there something I can factor or simplify? Not cube root, but the cube formula. The difference of cubes, in fact, for this one. So don't we go, I think this is the formula if you've forgotten. Minus goes minus, plus, plus. So this guy simplifies to x minus, what's being cubed to make 8? XA, what's A again? 2, so this would be 2x plus 2 squared is 4. Okay, so that's really on top, and then on the bottom we have x minus 2. It's all equal to 6. Does anything cancel on this one? Yeah, I made it, so it did. And then see, I didn't think about the end of this problem, so I don't know what's going to happen. We're left with a parabola. Solving parabolas, we either factor like we've been doing for all this stuff, or like quadratic formula, or use our calculator. It's kind of up to us. Let's set it to 0 first though, right? So you go 0, x squared plus 2x minus 6 minus 6. Does that factor? You got one choice, 2 and 1. I don't think so. So our only resort, well, we have 2 resorts. We can either quadratic formula or we can calculator. Should we use the calculator just to remind ourselves that that's possible? I think we should. And then we'll be able to see right away if we have some answers, right? So I'm going to stick my calculator out and let's see what happens with that. This one out of the way. Let's have a look. So, what have we got? Oh, I'm in polar mode from calculus. Let's go back to regular functions and just graph that parabola. I'm not graphing the original problem, the rational expression. I'm graphing the simplification. So I've got, I want to look and see where the x-intercepts are for x squared plus 2x minus 2. Zoom 9. Ah, looks like it has 2 answers, doesn't it? Zoom 9. Doesn't like to do it. Oh, it's not Zoom 9, that's for statistics, right? Zoom 6 is for graphs. Silly me. Okay, looks like we have 2 answers. Quadratic formula would have given us them as well. So second calculate 0, right? So then I go left-hand side of that one, right-hand side of that one, and guess at it. So I get x is approximately 0.732. That doesn't violate my domain. I think I'm good. The other one is going to be second, calculate 0. You guys need to make sure you can do this. Tracing this is not good enough. So we need to go on the left and the right, and uh-oh. That's about where it is. All right, so there's the other one. Negative 2.732. So while I have my calculator out, I'm just going to check one of those. They both look okay. I'll tell you, there's a bunch of problems of yours that will have extraneous solutions. How are you going to know? You have to check them all, like I'm going to show you this one? No. You should just look and be like, what would cause a problem if it were a candidate answer? 2. If I got 2 as an answer out, I'd be like, whoa, whoa, whoa. That'll be like dividing by 0. It's not actually going to work. So just keep an eye out on the denominator here. Okay? So let's check just to make sure one of these works. So I'm going to put it back in the original equation, right? So here we go. I'm going to say, now if I round it, is it going to be perfect? Is it going to work just right? No, but that's okay. So I'm going to get a fraction going. I'm going to go 0.732 raised to the 3rd power, right? Minus 8. Then on the bottom, I'm supposed to go x 0.732 minus 2. And since I rounded, it won't be perfect, but it should be close to 6. Which it is. Like I said, the only extraneous answers you're going to run into on this, and you will run into a lot of them, is if it happens to be the bottom. And a lot of these were engineered to have extraneous answers, so to see if you're actually aware. Okay? All right, I'll see you next time.